So one thing I think we're asking is how many atoms are in a particular substance. Let's say I give you there's 2 grams of this. Okay? Oh no. What's the number of C atoms, for example? Okay. So first there's a number of carbon atoms in the molecule. How many carbon atoms are in this molecule? Not 6. Should get 7. They're around the hexagon. There's 6. 1, 2, 3, 4, 5, 6, 7. So there's 7 per molecule. But I don't care about 1 molecule. I care about 2 grams of this stuff. So that could be one question. Count the number of atoms in the molecule. Like I could also ask you how many hydrogen atoms are here. That's another possibility. But for the 2 grams, you would say, well, there's 2 grams of that thing, whatever that is. I need to change this to moles. Okay, so I'm going to put here the molar mass. I just made this up, so I don't have the molar mass, but you can calculate that. Okay, and then so that's the moles of that thing. And basically now I want to do a conversion and say there's 7 moles of carbon atoms per 1 mole of that, I'll just call it the molecule. And by molecule, I mean this whole thing. So by molecule, I mean that. Okay? So if you do that, you now have the moles of carbon. But I didn't ask for moles of carbon, I asked for how many carbon atoms there are. And so to get to atoms, you use Avogadro's number, 6.022, whatever, times 10 to the 23rd atoms of carbon per mole of carbon. And that calculation would get you to the number of carbon atoms in 2 grams. Again, if I asked you the number of carbon atoms per molecule, you'd just say 7. Okay? Pretty typical question in a multiple choice. Yes? Okay. For fun, let's count the hydrogens. I'll give you about a 10-second head start on how many hydrogens are in here. Number of hydrogens per molecule. Okay, I'm ready. What do you get? I think I got more than 6. There's 2 here, because there's got to be 4 bonds for every carbon. There's got to be 1 here then, because that only had 3. This only had 3, needs 1 more. This only has 3, needs 1 more. This only has 3, needs 1 more. This only has 3, needs 1 more. And this one needs 1 more. How many is that? 2, 3, 4, 5, 6, 7, 8. I got 8. Every carbon must have 4 bonds. Make sure that's happening. Okay. Next. Oh. Great. How many sig figs should I have in my answer? Anybody? 2. That's right, because it's multiplication. And so you're going 2 here. Okay, that's eliminating. This is going to have, based on the periodic table, which you usually get about 4 from the periodic table. This is exact number. There are exactly 7 carbons in the molecule. And then this is 4. So we're going to limit it only by this one, 2. Great. Okay, next. Let's try oxidation states. All right, let's try some molecules here. So I want the oxidation state of the labeled atom. I'll do kind of medium to difficult, a couple difficult ones. Oh, I have a monster in my mind here. Oh yes, I'm really loving this right now. Oh no, not a 2, a 3. 2 there. Oh no, I guess. Let's put a 2 there. Yes. Yes, that's beautiful. Okay, phosphorus. Go ahead and get started if you want to try the first one. You're going to come up with one more pretty tough one here. first. What would be the name of the first one? Calcium what?
Thiosulfate.
Thiosulfate. It's one of your polyatomics, the thiosulfate is. So, you know a thiosulfate, or you will by the exam, has a charge of what?
+2.
-2. The calcium is +2 from the periodic table. Thiosulfate is -2. So that means down here on scratch, 2 sulfurs plus 3 oxygens. What's the common charge for oxygen? -2 equals the overall charge of -2. So 2 sulfurs minus 6 equals -2. 2 sulfurs equals 6 minus 2 is 4. Sulfur looks like it's going to be 2 for that one. Okay, so this is just my scratch work here, Brown. Okay, next one. What's the name of this? Magnesium dihydrogen phosphate. This thing is also one of your common polyatomics. It's called dihydrogen phosphate. What is the charge on dihydrogen phosphate? -1. So I'll rewrite it here. H2PO4 -1. It's 1 off of phosphoric acid. What's the common charge for hydrogen? +1. Oxygen common charge? -2, just like the other one. Oxygen is usually -2. So we've got 2 hydrogens at +1. We've got a phosphorus, which is the one I want to know. We've got a phosphorus, which is the one I want to know. We've got 4 oxygens at -2. And that all equals -1, the overall charge of the molecule. Well, that means phosphorus, 2 plus phosphorus -8 equals -1, or phosphorus is going to equal +5 if you move everything over to the other side. Okay, +5. Let's do the last one, then I'll see if there's any questions. I totally smudged it though. There we go. There's the last one. For the last one, let me rewrite it. Copper, there's 2 of those things, 2 of these. I meant to put 2 of those. 2 of these. Okay. This would be a more higher level difficulty one, but you sometimes see them on exams. Okay. You need to see what you recognize. You recognize that. We call it water. It has a charge of 0. Cool. We call that ammonia. Has a charge of 0. We call that specifically a hydroxide ion. It has a charge of -1. So you just set up an equation just like the previous ones. Copper, which is the one you want to know, plus 2 hydroxides at -1, plus, oops, I forgot 2 here. I didn't carry it down. 2 ammonias at 0, plus 2 waters at 0. What's the overall charge of this monstrosity here? 0, and you know that because there's no number right there. There's no number there, the overall charge is 0. So we'll do a little math, and it turns out to be pretty easy. Copper -2 equals 0, or up here, copper equals +2. Does that answer make sense, by the way? Why does it make sense? It's one of the 2 common charges. Copper is +1 and +2, and it all adds up nicely. Okay? All right, I'll pause for a moment. Any questions on oxidation states? What's that? Magnesium. Yeah, there's 2 ways you could look at it. You could, for the second one, you could consider the magnesium charge +2. That would help you if you forgot the charge of the dihydrogen phosphate ion. I didn't, I know it was -1. But if you did, which could happen on the exam, they just say magnesium is +2, and since there's 2 of those dihydrogen phosphates, it must be -1. It's the only way to balance the molecule. But if you straight up recognize it, you don't have to mess with the magnesium at all. Okay. Next. Yeah, I just want to make sure we get it through a ton of content here. Combustion analysis. So for combustion analysis, true for any of these, If I don't hit specifically what you were curious about, make sure to ask me in the second half of this. I don't think I have a combustion analysis question per se, so I'm going to go through the flow of the problem. And then if one of you wants to ask me a specific question after this, when we get to specific questions, I'm happy to solve one in particular for you. Okay. So, there's a couple key items to combustion analysis. Let me break it down for you. You're going to have a molecule in the question that has a carbon, a hydrogen, and I'll put X and Y. We don't know the ratio of carbons to hydrogens. And I'll put this in a different color in green, maybe an oxygen, which also adds another ratio. So I just put a different color to represent there could or could not be oxygen. It's going to say the word combustion in the question, okay? And then it's going to have, either in words or as a formula, you'll see CO2 and H2O, carbon dioxide and water. For both of these, you must be given a mass. So for both of these, you're given mass. So you'll have a mass in grams for CO2 and H2O, and you'll be given a mass of that thing right there. So you have to be given a mass of, there are 3 masses you have to have. CO2, water, and this thing. And I'll basically ask you for the empirical formula. So what you're going to do, let's just assume, I'll put this in brown. Let's say you had CO2, and let's do it for H2O, it'll be more fun. H2O, let's say they gave you a mass of 0.050 grams of water. I'm just making up a number, okay? Let's say they gave you that number. You're like, what the heck do I do with that? Well, you're going to follow the same steps, so I'll put all the same steps in black. You need to get to moles of what? Hydrogen. Moles of hydrogen from here. Moles of hydrogen will be equal to what variable that is right now on this page? Y. That's right. Oh, I thought quicker, it would sound like you didn't know the answer. Okay, you got Y. But I wasn't fast enough, it's too late. Okay, so the molar mass of H2O is 18.0 grams. 18.02 grams from the periodic table. So get that from the periodic table. Then this is moles of H2O. You need moles of hydrogen. There are 2 moles of hydrogen for every 1 mole of H2O. Or in other words, there's 2 hydrogen atoms in a water molecule. So this will get you to moles of hydrogen, and that's going to equal Y. So that'll be a number, and you'll go through that calculation. You are then going to do the same calculation for CO2. But what's going to be different? The molar mass will be different. And what's this molar ratio going to be? Not 2 to 1, but 1 to 1, because there's 1 carbon atom in every CO2 molecule. So that calculation, same calculation for CO2, this will get you moles of carbon, which is equal to X on this page. Okay? So you're pretty much halfway there. If there's no oxygen at this point, what would you do next if there's no oxygen? You divide by the smallest, whether it's X or Y, and you get to the whole number ratios, and you are now using the law of multiple proportions when you do that. Okay? All right. If there's an oxygen, you have some more joy to go through right now. Okay? If oxygen, okay, so if there's oxygen, then you have a couple more steps. You need to find the grams of carbon and you need the grams of hydrogen. How will you find the grams of carbon and hydrogen? The moles, you're technically multiplying by what? You have the molar mass of carbon, you 12.01 grams per mole, or hydrogen 1.008 grams per mole. So you need to convert to this. And then you're going to use the following. The mass total equals the mass of carbon plus the mass of hydrogen plus the mass of oxygen. Or in other words, the mass total, let me zoom out a little bit so you can see the whole page here. Okay. The mass total is the given mass of that thing. We're basically saying that the total mass of this entity is equal to the sum of its parts. So the mass of this thing is equal to the mass of carbon, which is right there. It's equal to the mass of hydrogen, which is right there. You have those two, plus the mass of oxygen. And that's what you want to know. You'd want to find the mass of oxygen. What do you think you would do once you find, I'll write that down, find the mass of oxygen? What do you think you do when you find the mass of oxygen? What's your next step? Convert to moles, and that is equal to Z. Look at the top of the page. You're going to take this to moles of oxygen, and that equals Z. Look at the top of the page. It's equal to that variable. If there was oxygen and you just found the moles of oxygen, what would you do at this point? Divide by smallest, whether x, y, or z. Again, use the law of, or in this scenario, use the law of multiple proportions and change these to small whole number ratios. That's the flow. I'm happy to do an example at the second half of this. Somebody has one for me. Some of these others I do have examples. That one I just have. All right. Let's go to the next part.